Hello everyone, this is Pre-Calc Lesson 65, Radicals and trig functions and graph of logarithmic functions. So radicals and trig functions, we treat it like any other radical. Isolate the radical, square both sides. Okay? Always check for extraneous solutions. Sometimes often you can definitely get things that are extraneous. Okay? So let's do this example. We have the sine of x minus 1 minus the square root of 1 minus sine squared x, okay? I'm going to add my square root over. So I get the sine of x equals the square root of 1 minus the sine squared of x. And I'm going to square both sides. So I get the sine squared of x is 1 minus the sine squared of x. Okay? I'm going to bring everything over to one side, so if I add sine squared of x over, I'll get 2 sine squared of x minus 1 equals 0. And if I solve this, I will get sine squared of x is 1/2. So I get the sine of x is plus or minus 1 over root 2. Okay? Now, we know that that relates to my 45, 45, 90 triangle. So here, if I have the sine of 45 in this quadrant, then I get a positive 1 over root 2. Same thing in this quadrant, so 135. In this quadrant, and in this quadrant, I will get negative 1 over root 2, which I say plus or minus. So I'll have 225 and 315. Now, I need to check all of my solutions. Okay? So I'm going to plug it in here. Okay? Now, I'm just going to show you the ones that don't work, okay, but you need to check with all of them. So I'm going to look at the sine of 225. Does that equal the square root of 1 minus the sine squared of 225? The sine of 225 we know is negative 1 over root 2, so I'm going to write it as negative 0.707. But here, if I square that value, it becomes positive, and 1 minus that value is this when you take the square root. Right? Because this gives me a negative value, I know the square root cannot give me a negative value. So I can eliminate these two options because they would give me a negative 1 over root 2, which this cannot give me a negative 1 over root 2. So my answers are just x is 45 and 135. Okay, don't forget to check for extraneous solutions. Okay, let's do this next example. I have two things being multiplied to give me 0. That either means that the tangent of x minus root 3 is 0, or the sine of x plus 1 equals 0. So here I get the tangent of x is negative root 3, and the sine of x is negative 1. So I know that tangent, right, if we have all students take calculus, tangent is negative in the second and fourth quadrants. Okay. So I look here. Now I know of root 3. This is 60, this is 30. I have root 3, 1, and 2. The tangent of 60 gives me root 3. Oops, sorry, I'm adding this over. This should give me a positive. Silly, we should be in the first quadrant, not the second. So if x is 60, right, tangent of 60 gives me root 3 over 2. Tangent is also positive in the third quadrant at 240. Now let's look where the sine is negative 1. We know the sine is negative 1 when x is 270, but this point here is 0, negative 1. Think about tangent. Tangent of x is sine of x over cosine of x. So if we had the sine of 270 over the cosine of 270, we would get negative 1 over 0, and we can't have that. So 270 is an extraneous solution. If we put in 270 into tangent, we would get an undefined value. Therefore, x can only be 60 and 240. Okay, now let's look at exponents and logarithms. We've already talked about how exponentials can be any positive number except 1 in the base. Okay, any positive numbered base is what that says. Now we know it can't be 1 because 1 to anything is 1, so it would just be a straight line at 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, in logarithms, the base can also be anything except 1. If we look at our graphs, this is our exponential, this is our logarithm. They are inverses of each other. Now that helps us, as I'll show you here. So I'll show you both these examples. So let's graph y equals 3.5 to the x. Okay, we have our xy chart. I know that when x is 0, y is 1. Okay, and I need another point. Let's plug in 2 for x. So we have 3.5 squared, which gives me 12.25. So let's make this 2, and this is 12.25. So I know that this is my graph. I need one other point. Let's do negative 2. And it gives me 0.082, which is there. Okay, I want you to have these 3 points. Now, we know that the log of that same base, they are inverses reflected across this line. So what does that tell me for my log? I switch the x and the y's. So when x is 1, y is 0. When x is 12.25, y is 2. When x is 0.082, y is negative 2. So let's do 1, 0, 2, let's go all the way up. Say this is 12.25, y is 2, and y is negative 2 at 0.8. Okay? These are the exact inverses. If I was to sketch this graph up here, right, they're reflected across this line, which means if I can graph one, I can graph the other and just switch your x and y's. Okay, it makes it really convenient. So what your book will do, and what I suggest you do, is if you're asked to graph the log, graph it in exponential form, which we know is easier, as in you can plug in values in your calculator, and then you can graph the log. All right, that is all for today.